Do you know a single chip smaller than your thumb and made up of silicon is brain of your computer? It's present in phone, laptop, desktop computer, and power coding, gaming, multitasking with billions of transistors. When you set a task on PC, double rate data will get the data form RAM. The data is then distributed to L1, L2, L3 caches. Then cores will fetch the data from caches and perform the calculations and send the output to internal GPU of chip. And last, display control logic give final touches and show the video on monitor. This one cycle called clock speed cycle, which happened in 3.5 gigahertz, means 3.5 billion cycle per second, traveling nearly half of the speed of light. But how this tiny marvel turn electricity into digital life? What actually happening inside? Let's see in today's video. Intel 12th generation core processor architecture is Alder Lake hybrid architecture, which combine P-core and E-core. A game run on P-core for maximum performance and background tasks like music run of E-core to optimize efficiency. On a chip, there's 16 Raptor Performance Core design for intensive tasks. It can do hyperthreading, means switching to another work while waiting for data. This is achieved by duplicating some parts in core, like ALU, which we will see later. Then 16 Gracemont efficiency cores grouped in 4 and named as cluster. It do not support hyperthreading as it focuses on only a single and light task. To perform calculation, cores need data where they fetch from caches. L1 and L2 caches store frequently used data. P-cores have dedicated 2 megabytes L2 cache and cluster have their 4 megabytes L2 cache. And L3 store 36 megabytes. To establish the connection between all parts, there is a compute fabric with 18 metal layers made up of copper-form lattice structure. The first layers is local interconnect small circuits. Above it is intermediate interconnect to connects between cores, and then last global interconnect, which connects whole chip. Each layer is flat, and between the wires a dielectric slab to prevent electric interference. Metal layers are present on 25.7 billion silicon transistors. Structure of transistor is FinFET made up silicon, metal, and dielectric slab. It has source, drain, gate, and fin. When a voltage apply on it, current flow from drain to source, this type of transistor called NMOS, and when a current flow from source to drain, it is PMOS. NMOS and PMOS combined is CMOS. All of these used in calculations. In caches to store data, there is SRAM array, each of it store 1 bit. All of these arranged in ALU. An ALU input instruction consists of operand, just the bits, and opcode. Opcode tell which calculation to perform on operand. The ALU are designed for maximum efficiency while executing the cycle it fetch data. For next cycle, this is known as pipelining. It works with turbo boost mechanism, a chip sensor that maintain temperature below 100 degrees Celsius by making changes in frequency. There are approximately 64 ALUs in a chip. Output generated by ALU packed into memory buffer and transfer to GPU. Here graphic API organize data into structural formats. Vertex buffer plays coordinates for a 3D model. Index buffer connect vertices by lines. UV maps link vertices to texture and color. And the last render is sent to display control logic. It coordinates reading pixels from frame buffer and formatting them for output. Finally, we see image on monitor.